Math 230, Cuesta College. I'm Joe Vasta. We are going to be covering section 2.4. You might be wondering what happened to section 2.3. We skipped that. That's an optional section. So we're going to learn today how to shade Venn diagrams. So what does that mean and why is this useful? Well, we'll get to that. Before we get to that, the puzzle. How are the two sentences related to math? May I have a small container of orange juice and 3 pancakes? And the second one is, to impress a fraction of students, I remember to enumerate this short statement. What's up with those statements? Or those sentences? We'll get that at the very end of this video. So let us go ahead and talk about this right here. Draw a Venn diagram for each of the following sets, and we're going to shade the Venn diagram. Okay, so the first thing I'm going to do is draw a rectangle. We're doing problem number 1. And now we have 2 sets, and we use circles to represent the sets. And what we're going to do is make those circles overlapping. That's what I'm going to do. Okay, so maybe I'll say this right here is the universal set, and this is set A and set B. Now, when we do it this way, when we put the sets overlapping, there are the maximum number of regions that we can have when we have 2 circles, like 1, 2, 3, 4. If I made the 2 circles separate, I would only have 3 regions. And if I put one of the circles as a smaller circle inside another one, I would only have 3 regions. So this is a way of getting the most number of regions, is by overlapping the circles. So now what we want to do is, we're still not displaying what this is. What we want to do is we want to describe what this means. This means all the elements in A and in B. So all the common places. It means you're in the A circle. And remember, intersection means and you're in the B circle. So where are you in the A circle and in the B circle? You're in the A circle and in the B circle, right in the middle. So this is the region that gets shaded, and that region represents A intersect B. Now this is different than when we talked about apples and oranges and fruit and things like that. Now we don't know what the sets are, so this is the most general picture that we can draw. Let's go ahead and do problem number 2. Draw a Venn diagram for A union B. So I'm going to do the same thing. Here's the universal set. I know that looks like a crazy script U. And I'm going to draw 2 circles. And by the way, you can put letter A inside the circle and B inside the circle if you'd like. I'm just feeling in this kind of mood to put them outside the circle. So there's A, there's B. And this is saying, shade all the regions that are in A, or that shade all the places that are inside the A circle, or inside the B circle, and then this is the or both. So I'm going to shade A, so there's A, but I'm also going to shade inside the B circle. So maybe my coloring job is not the best, but this shading represents A or B, or both, A union B. So this is what we're doing. There's a lot of your homework is going to be this artwork where you're shading Venn diagrams. And we'll see the usefulness in that as we continue. Okay, now the problems are going to get a little tougher, and we're going to show you a way of doing the shading where you don't have to hurt your brain that much. So the next few that we do are going to be a little bit more complicated. So here we have this one right here. Okay, so problem number 3. I'm going to go ahead and put the Venn diagram right there. There's the universal set. Here's A. Here's B. Now, some of you may be able to think this out. Okay, you're not in the A circle and you're going to union that together with the B. Okay. But for most of us, what would be a simple approach is there are 4 regions, so I'm going to label them with symbols, and I'll just use numbers. So watch this. 1, 2, 3, 4. Now I didn't have to do that. I could have put the 1 there, the 2 there, and the 3 there, and the 4 there. You just have to have some sort of labeling technique. You could put a happy face here, a sad face here, a moon here, and a star there. We'll just do it this way here. So what I'm going to do is I'm going to go over here and I'm going to say, well, what is in the A circle? It's 1 and 2. Okay, so I copy down A and put a complement there. Remember, that is the complement. And then we're going to say U. And what's in the B circle? 2 and 3. The universal set contains 1, 2, 3, 4. So that will help us with the complement. And let's continue this problem here. So complement comes first. It's stronger than union. So the complement of 1, 2 is 3, 4. And so now I'll bring it over here. The union of 3, 4, and 2, 3, the union is the OR. What do you see in this set or both? Or think of this as the salad bowl. So we're just throwing it all together. We end up getting 2, 3, 4. Now we're not going to box the answer because the answer is not going to be this. It's drawing a Venn diagram. So what I'm going to do is I'm going to use this as a guide to tell me what I'm going to color. I'm going to color 2, 3, and 4, which is the outside. I was never a very good colorer when I was in grade school. There it is. That's the answer. So this part of your math class is sort of an art class, art part. I mean, this is not, is it really art? I don't know. Let's go ahead and do problem number 4. Why don't you pause the video and see if you can draw the Venn diagram for A intersect B. The whole thing is complemented. Okay, so I'm going to start by going like this. Here's the universal set. Here's set A. And there's set B. We number it. I'm going to use the same numbering scheme I did up there, but it doesn't matter how you number it. Like I said, if you had put 1 here, a 2 here, a 3 here, and a 4 here, then you would have had 1, 2, 3 as your answer. And you would have shaded exactly the same regions that I shaded. So I'm just going to go 1, 2, 3, 4. And I'm going to start by writing this out like I did the other problem. Circle A has 1 and 2 in it. Circle B has 2 and 3 in it. And there's the complement. And even though the complement is stronger than the intersection, parentheses are the strongest. So I'm going to do the parentheses first and see what I end up getting. So here's the claw. the common elements of 1, 2, and 2, 3, or the and. What do you see in the first set and in the second set? And what you see is just 2. Okay, so that's what the parentheses become. Then you have to complement it, okay, because that's on the outside. The complement of 2 is what is not 2. Well, it would be 1, 3, and 4. So that is what we're going to shade. We're going to shade region 1, region 3, and region 4. There we go. So I think we're doing pretty good. We have these two pretty pictures. And the next question says this: are these two sets, and those happen to be the ones that we just drew pictures of, are those two sets equal? Well, you know, to see if two sets are equal, they have to have identical shadings. Do those shadings look identical? And I'm not talking the color, I'm talking about where the regions are shaded. And no, that part is not shaded. Region 1 there. And then over here, region 2 is not shaded. So if they do not have the same picture, then guess what? They're not equal. The answer is no. And I've got to say that this problem right here is part of section 2.5. So when we do 2.5, we'll do another problem when we do that video, but it won't be that long of a section. So that is problem number 5. Let's go ahead and do a few more problems. Problem number 6. Well, what do you notice different about this problem? There's 3 different letters. So this looks more intimidating. Let's go ahead and do this problem together. I'm going to draw a bigger Venn diagram. Here's the universal set. I'm going to draw set A right there, set B right there, and now I want to put a third circle, set C, where I'm going to get the most regions, and that would be intersecting both of those circles. So you can count how many regions there are if you counted them. 1, 2, 3, 4, 5, 6, 7, and then the outside region, there's 8 of them. So I'm going to label this circle A, this one B, this one C, and I'm not saying you can't figure this out. Some people can. They go, okay, what's not in B, and then you union that with A using union as a verb, and then intersect that with C. So some people can figure it out that way, but a lot of us need to number this. And so we're not going to go 1 through 4, but now we're going to go 1 through 8. Any way we want to do that, I'm just going to go like this. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I've numbered it. And now I'm going to go over here and do the problem. Okay, set A, circle A has 4 numbers in it. 1, 2, 4, 5. Okay, then I put the union. Set B has 4 numbers in it. 2, 3, 5, 6. I put the complement there because you have it right there. Parenthesis. Intersect. C has 4 numbers in it as well. 4, 5, 6, 7. Whew, almost didn't fit it. So now, the order of operations say that I have to do parentheses first. So we can just cover up that part. And we are going to do what? Union or complement first. Well, complement's stronger, so we're going to do the complement of 2, 3, 5, 6. And remember, the universal set is 1 through 8, so I'm going to go ahead and simplify that. So the first one I'm going to leave alone. And this one right here, so what is not 2, 3, 5, 6? It would be 1, 4, 7, 8. Okay, the next step I'm going to do is the parentheses. I'm taking the union of these two sets, throw them all in that salad bowl, and see what you get. I'm going to write them in order and not put repeats. I mean, I'm going to include repeats, but I'm not going to write like 1 twice. So I'm going to go 1, 2, 4, 5, 7, 8. So hopefully I got everything that I was supposed to get. And then this intersect. 4, 5, 6, 7. Okay, so we're saying what's in this set and in this set, or the common elements, or here's the claw, it's going to pick up the same ones. And so what do we end up getting? We end up getting 4 is in both sets, 5 is in both sets, 6 is not, but 7 is. So it looks like my answer is going to be 4, 5, 7. And I better be careful and not say that's my answer, but that's going to lead to the answer. So let's shade region 4, 5, and 7. And that right there in that box is my answer. So this is how you do Venn diagram shading. Let me just mention something down here. Maybe I'll just use a new piece of paper. But before we do problem number 7, we've looked at this right here. When there was 2 sets, there were 4 regions. And when there's 3 sets, and when we say sets, we mean subsets of the universal set, there were 8 regions. Well, we've never done ones like this when there's just one subset in there, but if you just had set A, how many regions do you see? Well, 1, 2. And then one that you will really not see is if there were no subsets and it was just the universal set, how many regions do you see? You just see 1 region. Now this would suggest that there's a pattern. It goes 1, 2, 4, 8. Oh, it looks like a sequence. What's the next number that comes in that sequence? Well, it looks like it's geometric, and things are doubling or getting multiplied by 2. So the next one's 16. That would suggest that if you had to do 4 subsets or 4 circles, you would have 16 regions. Well, there's a lot of ways you can do it. Here's one that I came up with. This is a Venn diagram for 4 sets. I've actually made the 4th circle be this L-shaped D, and I'll count the regions. In fact, I'll number them so we don't count them twice or miss one. So 1, 2, 3, 4, 5, 6, 7, 8. You're not going to need to know this, and I think I've smeared some of the ink. 9, 10, 11, 12, 13, 14, 15. That looks like a 16. I'll make 15 here. 15, 16. There are 16 regions in there. So you don't have to worry about that. That's just for people who are interested. You can Google Venn diagrams for 4 sets and you'll see some different ones. There's one that has 4 like ovals, but it's kind of hard to draw. This one for me works like because I can draw it really quick by going to the center and then doing that quickly. Let's move on to the next problem. This next problem will be the last problem from this section. And so we are drawing a Venn diagram that is represented by that right there. So you might want to pause the video and see if you can do this one on your own. So if you don't know what to do, you could at least do that and feel like you're getting something accomplished. There are 3 different letters, so I'm going to go ahead and go, here's letter A, letter B, and C. There's set C. So there are 8 regions. I'll go 1, 2, 3, 4, 5, 6, 7, 8. And now we're going to go ahead and take a look at this. You can speed things up if you want. You could say, well, what would be the first thing that I would do? The parentheses. So this might be skipping too many steps for some people. I'm going to write out what I see in the A circle or the B circle or both. So I see 1, 2, 3, 4, 5, 6. So that yellow part can become 1, 2, 3, 4, 5, 6. There's the complement. And then this is intersected with C, and in the C circle is 4, 5, 6, 7. Okay, so now what I'm going to do is take the complement of 1 through 6, and that would happen to be 7 and 8. And now the intersection, the common elements in both sets would happen to be 7. So 7 is the thing that we want to shade. And that's the only one in this problem. So here is region 7 here. And so the application of this, besides making your refrigerator look pretty, is if you studied set theory, this would be a way of verifying whether 2 sets are equal or not. And we had done that earlier. So now I think we can get back to our puzzle. How are the 2 sentences related to math? So here it goes. Some of you may have figured this out. What you want to do is count the letters in each word. So look, this one has 3. I have 1, 4, 1, 5. Some of you see it and some of you don't. I'll keep going. And then container 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 6 letters in orange, 5, 3, the word 3, 1, 2, 3, 4, 5 has 5 letters, 8. So does this remind anybody of anything? 1, 3, 1, 4, 1, 5. Let's put a decimal point there. What do you have here? 3.14159, 265358. That happens to be 12 digits of pi. So that's pi. This one right here is one that you might not recognize, but that's the other very important constant in math. I'll write it down. So this one's 2718. There's 8 letters there. 2 8 1 8 2 8. So it looks like it's going 1828 1828, but look at this, 1 2 3 4, and then 5, and then statement is 9. So this is the constant E, and that's used in calculus. The pi has to do with circles, E has to do with growth and decay, and it's used in banking, engineering, things that have oscillations, etc. So we have, that is the puzzle. And some of you might not have liked this puzzle, but it is what it is. Our next section that we'll be going into, I believe, is 2.5.